Hi there, this video is for calculating drip rates, so get excited and let's get started. Alright, we've got our first problem here for calculating the drip rate. So we have 1,500 milliliters of LR over 12 hours, and we have a drip factor of 15 drops, GTT is drops, per milliliter. So knowing this, we're going to set up bidimensional analysis, what we know, and then put in our helpful conversion factors. So let's write down what we know. We have 1,500 milliliters to be infused over 12 hours. When we're looking for a drip rate, we're looking for drops per minute. Right now we're in milliliters per hour, but we have the information to get there. So we're going to put as a second part of what we already know, we're going to put drops. We're going to put in our drip factor here over 1 milliliter. So this is great. I already see something that's going to cancel out. We're going to cancel out the milliliters here. That's going to be giving us, though, drops per hour, and we're looking for minutes. So we're going to trade colors here and now put in what we had to add. So what we have to add is how to get to minutes. We know this. We're going to put an hour on the top because we need an hour up here to cancel with our hour down here. We're going to put an hour on the top and put 60 minutes because we know there's 60 minutes in an hour. So after all this, we're going to come on through and we're going to multiply them if we check that all of our units of measurement cancel out. So we're looking for GTT per minute. Do we have a drop on the top? Yes. Drop on the top. And do we have a minute on the bottom? Yes. Does everything else cancel out? Milliliters, milliliters, hours, hours. We are golden. We are left with exactly what we need. So we're going to multiply right across the top, and 1,500 times 15 times 1 is going to leave us with 22,500. So 22,500 over. We're going to do 12 times 1 times 60, which is going to leave us with 720. When we divide that, we're going to land on 31.25. So 31.25 drops per minute. Now, 31.25, you can't administer 0.25 of a drop. That would be ridiculous. So we're going to be rounding to the nearest whole number. In this case, we're rounding down. It's 25. So we're going to be administering 31 drops per minute. And if you really needed to, you could absolutely sit there and count 31 drops per minute for your patient. So this is really important to know. And let's try another. All right, we've got our second problem here. Patient is ordered 300 milliliters of ampicillin sodium, 500 milligrams to infuse over 40 minutes. Our drip factor is 20 drops per milliliter. Don't forget, we're looking for drip rate. So that is drops per minute. That is our ultimate, what we're going for here. So let's go ahead and pull out the important information and set it up using dimensional analysis. So first we have here, we see 300 milliliters. That is really important. We are talking about drip rate. What drips? Liquids, and liquids are measured in milliliters. This problem tries to throw you off, but you are smarter than it. It says ampicillin sodium 500 milligrams. You might be tempted to underline that. It's a big number. It looks important. But that 500 milligrams, it's just telling you that it's within that 300 milliliters. So this is the fluid we're working with. They could be getting 2 milligrams of medication in the 300 milliliters, but that's not what we're working for right now. We're working for how much fluid is going to be dripping into this patient. So it's infusing over 40 minutes. Time is always important, especially when we're working towards drops per minute. They already gave us minutes, so let's take advantage of that. And our drip factor, we're always thankful for our drip factor. So let's set it up as what we know. We have 300 milliliters infusing over 40 minutes. And this is so nice because last time we had to turn our hours into minutes because that's our end result that we're looking for, but we already have minutes, which is really exciting. So we also already know our drip factor, so we're setting up what we know. And when we look at it, we have milliliters and milliliters, which are going to cross off, leaving us with drops on top and minutes on the bottom, which is exactly what we're looking for in our drip rate. So we're already ready to solve. So we're going to multiply our 300 by our 20, and that is going to equal our 6,000. And we're going to divide that by 40 times 1, which is 40. We're confirming with our calculator, but it's 40. It's really jank 40. And then we're going to divide them, and we're going to get 150 drops per minute. And there you go. Is it logical? 150? Well, compared to our last problem, always use another problem as a source of reference as well. Our last problem had a much smaller drip rate, but it was being infused over a longer amount of time. Whereas this is in 40 minutes, so it makes sense that it's a bigger drip rate. So we're good to go.